Okay, YouTube, in this second video of my module on graphing quadratic equations, what we're going to focus on is quadratic equations that I refer to as being in proper standard form. And by proper standard form, I mean that some textbooks refer to standard form as this for a quadratic, and I would say that this is not standard form. This is what I would refer to as vertex form, and because it tells you the vertex. It's semantics. I'm just arguing semantics, but basically, standard form. I want to tell you that when you hear me say standard form, I'm referring to any quadratic equation in this form here, y equals ax squared plus bx plus c. And that being said here, what we're going to focus on is how we would graph out of this form here, knowing that vertex form, yes, is likely the easier of the two forms, but knowing that also there's a way for us to do this with y equals ax squared plus bx plus c. So let's go ahead and read through this here very quickly. It says the vertex of a parabola whose equation is in this proper standard form. Considering that equation, we say the parabola's vertex is negative b over 2a, f of negative b over 2a. So I'm just writing this for my own benefit over here. I'm writing here negative b over 2a is the x value of the vertex, and then f of negative b over 2a. Essentially, what we're saying here is when we want to find the x value of where the vertex is at, we could just find this value here, negative b over 2a, where b is this coefficient of x, and a is really just the leading coefficient, the coefficient of our x squared term. And that's it. That's all you got to do. Well, in order to find the y value, what this means is we're going to have to find this first and plug it in. So here's what I do want to at least do here. We say if I had a sketch of a parabola that was, this y equals a x squared plus bx plus c. What I would at least want to write are a few things on here. One is the axis of symmetry, yes, but the other one is this vertex value. So we say the vertex is negative b over 2 times a, and then what I get when I plug that into the function. So we're always going to need to know the negative b over 2a part. And then I would say that this axis of symmetry here, in the last example we said the vertex is at hk, so this is x equals h. But we would say that this also does have the same x value as our vertex. X equals negative b over the 2a. So the same x value. So knowing that the vertex is right there, I say that the x-coordinate is negative b over 2a. We say that the y-coordinate is just found by substituting the x-coordinate into the parabola's equation and then evaluate the function at that value of x. So really, this negative b over 2a thing sounds pretty important to me. So what you're going to see here, these 5 steps, are really kind of the same 5 steps that we took when we were in what I would call vertex form, what some would call standard form. But basically, we're always going to start by determining whether it opens upward or downward, and then follow that up with determining the vertex, and then working with x and y intercepts from there, and then graphing. Okay, so let's go ahead and take a look at this example that I've got here. It says graph the quadratic function, and I notice that this is in standard form. So it says use the graph to identify the function's domain and its range. All right, well, looking at this in standard form, a few things that I like to write down at least. Let's see if I can get this to respond here. Or a, b, and c. It's in standard form. Why not? We got to identify these things anyway. So negative 1, 4, and 1. And so here's what I want to start with. Actually, the axis of symmetry. I don't know why I'm writing that. Maybe because of habit here. But x equals negative b over 2a is the value we're trying to find. So if I've got this here, we could say, well, then x equals negative b over 2a. This is x equals negative 4, negative positive 4 over 2 times negative 1. Looks like we get a negative 4 over a negative 2, which is a 2. So really, really quickly here, what we want to do is we want to diverge from all of this and go over to the graph and put this on the graph. At x equals 2 is our axis of symmetry. I got to tell you, I know that the vertex has to lie on this right now. This kind of restricted where our parabola can be. Also this, I know that the vertex is at the point 2 comma f of 2. And this is a good habit to write it this way, but really what this means is we're going to have to go find where is our y value when x equals 2. So we're going to go plug it in. And so our function here, we've got the rule up there. We say going and plugging in a 2 for all of our x's, we get this quantity here. So we have a negative positive 4 once we square that, plus 8 plus 1. That's a negative 4 plus a positive 8 is a positive 4 plus 1 more is 5. So we know that our vertex value is 2 comma 5. So 1, 2, 3, 4, 5. So I just want everybody to know that that didn't take that long. And now I know this opens downward, by the way, so I'm going to label it on top of this 2 comma 5. It's just a little bit more work than what you have to do with vertex form. So now that we have this, we're actually really in really good shape. So we know that this opens downward. You might write a note there also. So y-intercept, x-intercept. Let me show you something about the y-intercept here. When we find the y-intercept, recall that we're finding what is our y value when we plug in 0 for x. And so I'll write this out this first time here, but you're not going to have to write this out every time. But just to show you that anything with an x really is just going to drop out, and what you get left with is just the constant value. So that constant value, 1, we would say that we have 0, 1 as a point on our graph. We're going to put this on here, and I know that our graph has to go through this point now, and because of symmetry, this is kind of 2 away from this axis of symmetry, we'll go to the other side, and I say that this is also a point on the graph. So we have 0, 1. We also have, looks like this would be 4, 1. So now also because our a value here is -1, as we go right 1 from here, we're going to go down 1, and we also have these 2 points on the graph. So you can see how I'm going to get something that looks like this right here. Now don't think that I've forgotten about the x-intercepts. I just wanted to get to a point where I could show you that if our graph is going to go through the x-axis here and here, we should get some x-axis or x-intercepts that are close to these points right here. So that's what we're going to do now, is we're going to solve for the x-intercepts on this. And so our x-intercepts, I would say that setting all of this equal to 0, really setting y equal to 0, we would get -x² plus 4x plus 1. So now because I'm trying to solve this, I would really rather have a positive leading coefficient there. So I'm going to take both sides times a -1, and I still get a similar equation. I get x² minus 4x plus 1. So what I would try to do here is I'd actually try to factor this first. And what I notice is that there are not two factors of 1 that sum to be a negative form. So this doesn't factor. So we have some choices. We can either complete the square or we can use the quadratic formula. So what I'm going to opt for here is the quadratic formula just because I already have these 3 values. So x, remember x is, if in standard form and set equal to 0, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plant these in here. We're going to say, well, I get x equals -b, and our b value here is 4. So I get -4 plus or minus the square root of, suppose this would be 4 squared since it's b squared, 4 times a. Now our a value is -1. Our c value here is +1. And then this is all over 2 times our a value, which again, our a value here is -1. So we're going to simplify this. This is all we need to do here. But these are our x-intercepts. I need you to know that these are the x-intercepts right now. They just don't look very pretty. So in here we get 16. It looks like 2 negatives make this a positive, and then I would take, 4 times 1 times 1 is 4. So we really get -4 plus or minus the square root of +20 all over -2. I know that +20 is the same thing as 4 times 5, and we really bring up the 4 here because it's a perfect square. So this is all over -2. And then I would say, okay, well, now I know the square root of 4 is 2, so we really get this, -4 plus or minus 2 root 5 all over -2. And because we have common factors here of 2, I'm going to divide everything by a -2 actually. Then I get a +2. This would become a minus plus, but just know that it really doesn't matter. This is going to become a 1 out in front. We say 5, and then down here I would get a +1. So our 2 roots, or 2 zeros, or 2 x-intercepts are these right here. And so we're going to say 2 plus or minus the square root of 5. We could have gotten this by completing the square also. But I am actually going to label these. We say this is 2 minus the square root of 5, comma 0. And that this is 2 plus the square root of 5, comma 0. And we can certainly get decimals for those on our calculator. So yes, I'm going to go ahead and actually get decimals for those. I'm going to have to do it in a really roundabout way, so I apologize. I just didn't want to open up my graphing calculator. We say, okay, so 2 plus the square root of 5. I'll do that one there. We say, how about the square root of 5 first? And then I'll add 2 to this. We get about 4.24-ish. So this right here we could say is about 4.24, comma 0. And I would say that reasonably 1, 2, 3, 4 and some change, that's not very bad for me getting my graph right there. And I would actually maybe find this as a decimal on your calculator as well, 2 minus the square root of 5. I'm going to skimp on that right now. So we say the domain of this is -infinity to infinity. Of course it goes left and right forever and ever. I suppose I could sketch the rest of my parabola now. And I would say that the range, this, because it opens downward, has a maximum value. I'm going to list that here. But the maximum value occurs at 5. And we would say that this graph goes from -infinity all the way up to 5 and including 5.